Good morning, learners, and welcome to our today's math lesson. As you know, we had begun algebra, and we had done a few things about algebra. I want us today to discuss the questions, and in our questions today, we are going to see how to solve them, to simplify them, and come up with a number, a digit that represents that particular unknown. Just to remind you what we did before we went for our compulsory holiday is that we were doing some questions like 2p plus 3x plus x plus p, just like that, and I told to the group like terms together. Remember what we said, Lana? We said you pick the ones with the like terms. These are the like terms. We have 2p here and we have p here. So you write 2p plus p plus 3x plus 3x. Let's write it like that so that it doesn't look like a multiplication. So from there you can be able to begin and continue working out whereby this x, whereby you take 2p plus p, that will give you, Lana, here we have 1p, but you don't write that 1p. What we do is we write p because it's only 1. So the number before the p is 1, so we don't write it. Unlike here, but when the other number exists 1, then it becomes 2 and above, you can write that, we write that number. But here because it's 1, we don't write it. So we assume there's 1 there. So you get 2 plus 1, you get 3, then you get, just write p. So that 3p plus 3x plus x. There's a 1x here. We don't write that 1. But now we take 3x plus 1x, that will give you 4x. So that's how, Lana, we are doing our questions. But today I want us to remind ourselves by having one question here that we can be able to discuss. And this question is going to be a fraction question, whereby we are getting 1 over 6 t plus 1 over 3 t plus half t. Just to remind you what we did in class 5, and we are talking about the LCM. If you look at this one, these are not all numbers, they are fractions. So whenever you are adding or subtracting using subtracting fractions, you must use LCM. So how do we get LCM? You are told in class 4 that in a fraction we have two numbers. Like if you write half, we have two numbers there, the top number and the below number. So the top number is always called numerator and the below number is called denominator. So whenever you are adding or subtracting fractions, you deal with the denominators. There is where we get the LCM from. LCM in this case means the least common multiple. So this is how we get it. So you write 6, you write 3, and then you write 2. You want to get the LCM. So we are looking at the least number that can divide any of this number, any of those numbers, not all the numbers. When it becomes all the numbers, that becomes GCD. So which number is the smallest that can divide n of this number? You realize that number which is smallest can divide n of this number is 2. So 2 can divide 6 to get 3. 3 cannot divide, so you write it the way it is. 2 can divide 2 to get 1. From there, you have exhausted 2 because there is no multiple of 2 here. So you move to the next number. After 2, we go to 3. So our next number is 3. 3 can divide these numbers here. 3 divided by 3, you get 1. Then 3 divided by 3, you get also 1. So you drop this one here. So remember, in LCM, the number that you get at the bottom should be 1, 1, 1. Meaning that all the numbers have been divided fully. So where do we get our LCM? You take 2 times 3. So 2 times 3, that will give you 6. So our LCM in that case will be 6. So you now want to add these numbers. So after getting the LCM, we want to add. We have seen our LCM is 6, and so we bring our 6 down here. Then we say 6 divided by 6. We divide with the denominator, then multiply with the numerator. So here we divide, and then we multiply. So 6 divided by 6 is 1. 1 times 1 is 1. Then we add. So it is 1t, which you can write t. So instead of writing 1t, just write t. So you write t or 1t plus 6 divided by 3 is 2. 2 times 1 is 2. 2 times t is 2t. So here write 2t plus 6 divided by 2 is 3. 3 times 1 is 3t. So you write 3t. So now after we've done that, we add these numbers. T plus 2t is 1t. This simply means 1t. 1t plus 2t is 3t. 3t plus 3t is 6t. So here you write 6t over 6. 6t over 6. Lana, when it's 6t over 6, remember what we said? If a number that is on the numerator is the same as number on the denominator, that simply means 1. You divide by 4, 1 by 4, 1. That will give you 1. So this number is equivalent to 1. 4 over 4, we can write it as 1. So in this case, 6 over 6 can be written as 1. And so this will cancel and you remain with 6. You remain with t. So our answer becomes t in that case. T in that. In case that number did not simplify, assuming we had 3t over 6. So this is what we do, learner. You see, if they can be simplified, you just simplify this one by 3, 1 by 3, 2. And so you write 1 over 2, then you represent the t there. The t must appear there because we are talking about unknowns. So that's just one example. I give you the second example and then we move on to our today's work. Our next example will be AC plus 3c minus 2c. We want to simplify that. You realize that I told you if a number is written from beginning here, that number has a positive sign. So its sign there is plus, so we don't write it. So here is plus, this is plus. So we are talking about grouping like terms together. This one has an addition, this also has an addition. So we put them together. 8 plus 3, you get 11c. Then now minus 2c. This c has a negative sign. A number has a sign to the left side of that number. For this, the sign of this 3c is plus. The sign of this is plus. The sign of this is plus. So if you do that, exactly you get 11 minus 2. You take this minus this, you get 9. Then you write the unknown, 9c. So you can easily simplify that to that. So now we have known where we left. And so now we want to do equations. Equations from the word equal. Meaning that there's an equal sign. As you have seen here in these two questions I've done, there's no equal sign. So in this case, we are going to experience questions that have equal sign. So this is what we do. I want to give an example here of equations. And I want to draw something here. If you have a beam balance, just like that, and here you have 2t, then 2t, and then this is 8. Meaning that if they are balanced, if they are really balanced, then means this side is equal to the other side. This side is equivalent to that side. Meaning that if that side is equal to that side, we are going to add, so this one represents an equal sign. If they are balanced, look at this one is at what we call equilibrium, meaning that it's at rest at the same angle. Now this is going to be our equal sign. So we are going to say 2t is equivalent to 8. Because if they are balanced, that means that whatever is in this bag has the same weight or mass as the one on the other bag. Meaning that whatever is on this side is the same as what is on the other side. So we are going to divide, because we don't want 2t, 1t. So we divide by the number that appears before t. We call it coefficient, though it's not a term that we're supposed to use in class 6, but just for general knowledge, we call it coefficient. So the coefficient of t is 2. So the number that appears before 2, just get it like that. So we are going to divide by that number appears before t, and therefore that is going to be, our t is going to be by 2, 1, by 2, 4. 8 divided by 2 is 4. So our t in this case is going to be represented by 4. Let's see whether it's true that our t is 4. This means if you take the 2, you multiply by the value of t, you are supposed to get 8. And this is what we do. 2t means t plus t, and our t is here 4. So 4 plus 4 is 8, and therefore this is 8 and this is also 8, meaning that this equation is correct. I think you have seen that, learner. So I want us to move to another example whereby we are going to pick questions here. Like we can have 3x plus 5x is equals to 56. 3x plus 5x is equals to 56. Look at this, learner. This is 3. So we pick the numbers. They're all numbers. 3 plus 5, you get 8. And then you place the 6 there. You don't write 2x. No, you write x, only 1x to mean it represents the 2x. So that is equivalent to 56. So before you can be able to divide, you must group these together. There is no way you can start dividing by 3, then by 3. It's wrong. You must add them together if they look alike, if they are the same. So this is going to be, we don't want 8x, 1x, one single x. For us to get one single x, we are going to divide by the number that appears before x, which is 8. You divide by 8 on both sides. What you do on the left hand side, you must also do the same on the right hand side. So by 8, 1, by 8, 1. So here you're going to remain with x is equals to 8 get here 7 times. So our value of x is equals to 7. And there is true, if you get, this means 3x, meaning that x plus x plus x. Our x's we know 1x is 7. So if you add 7 plus 7 plus 7, you get 21 plus 5x. So 5 times 7 is 35. 35 plus 21 is 56, meaning that now this side is equivalent to the other side. If you get a number that is not equivalent to the other side, then you can never get that question right. We are going to move on to another example whereby you are picking, let's pick another example here, whereby you're going to say 2a plus 4a is equivalent to 42. 2a plus 4a is equivalent to 42. Now these numbers are the same, meaning that we are going to put them together. So this means 2 plus 4, you get 6, and then a is equals to 42. We don't want 6a, we want a single a. Divide by 6 on both sides. Just like that. So our a is going to be 7. So a is equals to 7. So that becomes your answer. There are examples that you can have whereby maybe you are given a question like this, Lana. I want you to look at this question. That 9x minus 2x is equal to 35. Now this is not addition, so what are we supposed to do? In this case, we are not going to add, we are going to subtract. So you are going to get 9 minus 2, you get 7, then you represent, the x must be there, whether it's subtraction or addition. So it's going to be 7x is equivalent to 35. And therefore you divide by 7 on both sides to get the value of x. So x is going to be by 7 1 by 7 5. So x is going to be 5. So Lana, the x remains, the unknown remains whether it's a subtraction or addition. That's what I want to show you. Then you can have another example, just like w divided by 5 is equivalent to 12. Now that's where we have a problem, Lana. When they have given you this type of division, what do? That is very, very important. There are two ways of doing this question. W divided by 5 is equal to 12. Remember, Lana, we have learned all about reciprocal, where we can be able to change a number like 2, the reciprocal of 2, this simply, if you want to get a reciprocal, if it's a whole number, write it over 1, meaning that there is a numerator and a denominator. How do you get a reciprocal? When you get the denominator up and the numerator down, you have gotten your reciprocal. Meaning that this is going to go up, going 1, and this is going to 2. So the reciprocal of 2 is 1 over 2. So in this case, we are going to use the reciprocal first. So this is going to be W, and then we will not use this type of division. But for the reciprocal one, we say, now we want to change this sign to multiplication. Reciprocal enables us to change a sign from division to a multiplication sign. How? We are going to write this as a number with a denominator. So this simply means times, it's supposed to be 5 over 1. So let me write it 12, so that you can be able to see that W divided by 5 is equals to 12. So let's write this with the numerators. W over 1 divided by 5 over 1 is equals to 12 over 1. These numbers are all numbers, so they are going to have a denominator which is 1, all of them. So that you can get reciprocal, we must have a numerator and a denominator. So this is going to be W over 1. This sign is going to change. So whenever you get a reciprocal, the sign changes. So it's going to be multiplication. So W over 1 multiplied by 1 over 5 is equivalent to 12. So the only number that changes is the second number, not the first number, not the other number there. So the second number changes to get reciprocal. So this is going to be W over 1 is times 1 over 5 is equivalent to 12. Now from there, Lana, you can be able to see that our LCM here is 1, 5, and 1. Whenever we have an LCM that is 5, our number that is a number more than 1 and a 1, the bigger number becomes the LCM. But in this case, if you want to get this, we must multiply the numerators alone. The numerators will be W times 1, which is W, over 1 times 5 is going to be 5. Is equals to 12. This is over 1. So now we have an LCM 5 and 1. So we are going to get the LCM as 5. 5 divided by 5, remember I told you we divide, then we multiply. 5 divided by 5 is 1. 1 times W is equivalent to 5 divided by 1 is 5 times 12. That's going to give you 60. So our W in this case is going to be 60. It is true. If you take 60 divided by 5 is 12. So that's how we get it learned. Now this is method number 1. Let's look at the method number 2. Now in our method number 2, we are going to say W divided by 5 is equals to 12. From there is another way you can be able to write this division sign by getting it as W and write this as over. This one also means division. If you write something like 3 and then slash 5, this means 3 over. Over means divide. So we are not going to write this division. We are going to write the other one, this one, over slash. Because if you write this one, we may not get the answer. So this is method number 2. So this can be written as W over 5 is equivalent to 10. From there, Lana, we don't find the LCM. We multiply direct. So multiply both sides by the LCM. Multiply by 5. Multiply by 5. So this 5 is going to cancel with this 5. You are going to remain with W is equal to 12 times 5, which is 60. So there are two ways of doing that question. Either you use the LCM way, or you move again and without looking for reciprocal, you just write this as W over 5 and then you multiply both sides by the LCM, which is 5, and get your answer. Let me do a final one of that nature so that I can give you at least a few questions that you'll be able to try. So I will write another question. K divided by 9 is equals to 21. How are we going to solve this, Lana? We are going to use method 1 first, whereby you are going to say K over 1 divided by 9 over 1 is equals to 21 over 1. After there, we get the reciprocal of the second number. So this is going to be K, and this sign will change. Multiply by, this is going to go up, this is going to come down. 1 over 9, this over 1 is equals to 21 over 1. Therefore, this is going to be K times 1 is K over 1 times 9 is 9 is equals to 21. From there, this is 21 over 1. You get the reciprocal. Sorry, the LCM. 9 and 1 LCM is 9. 9 divided by 9 is 1. 1 times k is 1k, which is written as k, is equivalent to 9 divided by 1 is 9, then times 21 is 189. So this is going to be 189. So the value of k is equal to 189. Then we move to way number 2, whereby we are getting the question direct. So this is what happens. K divided by 9 is equivalent to 21. So this is written as k, in another form is k over 9 is equal to 21. From there you multiply both sides by the LCM. Now this will cancel, they will divide. You remain with k is equivalent to 21 times 9, and that is going to be k is equivalent to 189. So there are two ways of doing that question, learner. So without wasting a lot of time, I want you to try exercise, let me write it here, exercise 28. Exercise 28. That is on page 38 of the primary maths. This is primary maths. Primary maths. Page 38, exercise 28, page 38. I want you to try questions number 1 to 10. Questions number 1 to 10 as practice questions. After doing them well, you realize that you can be able to solve any question when you are given an exam. So until next time, learner, I want to wish you well. Stay at home, stay safe, and sanitize. Thank you and God bless you.